Welcome back to First Principles Daily, episode 15. Today's question: what would this cost if you only paid for the atoms? Prescription glasses retail for hundreds, yet contain just dollars of polycarbonate and metal. Why hasn't the cost fallen toward the material floor? Walk into any optical shop and a finished pair of prescription glasses can easily leave the counter at $300 or more. The lenses themselves are molded from a few grams of polycarbonate or similar polymer. The frames come from acetate, titanium wire, or injected plastic. The hinges and screws add only grams of stainless steel. Those raw inputs together sit in the low single-digit dollar range at commodity prices. Yet the final ticket price stays stubbornly high because layers of custom work, regulation, distribution, and professional services sit between the material and the wearer. The conventional path begins with a refraction exam performed by an optometrist or ophthalmologist whose time and equipment must be compensated. That exam often happens under rules that tie the prescription release to the same visit. Once the prescription exists, the patient selects frames from a limited in-store inventory whose wholesale cost already includes brand licensing fees paid to fashion houses. Lens blanks arrive from a handful of large manufacturers. They are shipped to edging labs that cut them to the exact frame shape. Then the lens is returned to the retail location for final fitting and adjustment. Each handoff carries its own margin, insurance paperwork, and carrying costs for unsold inventory. Vision insurance further shapes the stack by reimbursing only certain providers and lens packages. This reduces price transparency and keeps many transactions inside the insured network. Independent practices must also cover the cost of sophisticated lensometers, pupillometers, and edging machinery that sits idle between patients. Those capital expenses are amortized across relatively few units. The result is a finished price that feels normal inside the industry, even though the physical object remains simple. Most participants accept the structure because changing any single step risks losing referrals, insurance contracts, or regulatory compliance. Online sellers have chipped away at frame and basic lens margins. Yet they still route prescriptions through licensed channels and often outsource edging. So the core cost stack persists. The system therefore reproduces itself year after year because each actor optimizes inside the existing rules rather than questioning the rules themselves. A rough magic wand estimate starts with the lens material itself. Commodity polycarbonate pellets trade in the low dollars per kilogram. A finished pair of lenses might use 40 to 60 grams once edging waste is counted. That places the polymer cost well under $1. Acetate or titanium frame stock adds another $1 to $2 depending on the alloy or polymer chosen. Hinge hardware, screws, and nose pads contribute perhaps 50 cents in stamped or cast stainless steel and small molded parts. Energy for melting, molding, and edging the lenses at industrial scale is measured in watt-hours per pair. That adds only pennies at grid prices. Summing these commodity inputs produces a floor on the order of $3 to $7 before any shaping or assembly labor. A $300 retail pair therefore carries an idiot index somewhere between 40 and 100. To arrive at that range, divide the retail price by the material floor. 300 divided by 7 gives roughly 43. 300 divided by 3 gives 100. That ratio tells us the dominant costs sit far downstream of the atoms. The first major adder is the refraction service and the regulatory requirement that a licensed professional generate the prescription. Even when performed efficiently, this step injects tens of dollars. Next comes frame branding and wholesale distribution. That can double or triple the factory cost of the frame before it reaches the shop. Edging and glazing remain largely manual or semi-manual operations at many locations. So skilled labor and machine time per pair stay high. Retail rent, staff wages, and the need to carry hundreds of frame SKUs compound the total. Insurance processing and returns handling add still more overhead that is invisible to the final price tag, yet baked into every transaction. Because each of these stages evolved separately, none of them is optimized against the others. The cumulative markups produce the observed gap between material floor and retail reality. A redesign would first attack the measurement step by validating whether remote or self-administered refraction tools can generate clinically acceptable prescriptions for the majority of simple corrections. That would lower the cost and friction of obtaining the numbers. Second, standardized digital frame and face scan data could allow centralized high-throughput edging lines to cut lenses to exact specifications without repeated physical shipments between lab and shop. Third, modular hinge and temple systems designed for automated assembly rather than hand adjustment could reduce the variety of parts that must be stocked and fitted on site. Each of these moves requires supporting conditions. Regulatory acceptance of verified remote refraction in more jurisdictions is one. Open file formats for lens and frame geometry so that any compliant edging machine can read the data is another. Enough order volume to justify continuous automated production lines is a third. The genuinely hard constraints are those rooted in medical safety. Complex prescriptions, prism, or progressive lenses still benefit from in-person verification. Improper fit can cause discomfort or safety issues while driving. Yet even if only the simpler half of the market moved toward the material floor, the arithmetic suggests the retail price for that segment could drop by a factor of 3 or more while preserving clinical standards. The prize is therefore not a complete elimination of professional services, but a separation of the commodity manufacturing steps from the steps that truly require scarce expertise. A finished item whose price greatly exceeds its raw material value is announcing that design, process, or regulatory choices dominate the cost, not material scarcity. Questioning which steps actually require human judgment or physical presence often reveals entire layers that can be rearranged or removed. Tomorrow, the show will examine another concrete case or another domain where the same gap appears. The first signal that someone is attempting this with glasses would be a published peer-reviewed study showing remote refraction accuracy matching traditional methods across a large patient cohort, followed by regulatory language that accepts those results for routine prescriptions. That's First Principles Daily for today. If this changed how you see what things cost, share it with someone who'd appreciate it, and subscribe wherever you listen. I'm Patrick in Vancouver. One example or one opportunity every day. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at Nerra Network. Links in the show notes. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.